Hello, this is our final project for ECE 3710. We are both juniors in electrical engineering at Utah State University. My name is Logan Voigt.
My name is Zane Winkler.
And this is the solar system scale. So what we wanted to do was provide a use for a bathroom scale. Most people have one, but don't seem to use one because they don't like to see the numbers that it displays. So we made ours be able to tell you your weight on any planet in our solar system, as well as in a variety of units.
There's 4 load scales underneath this panel that makes a Wheatstone bridge. As weight is put onto the Wheatstone bridge, it raises the resistance within those cells and increases the voltage, sending a signal to an amplifier. This amplifier then sends us a 24-bit piece of information into our LCD, which then can be manipulated with our key code to change the weight to whether you want it to be on a different planet or in different units. And so if you come over here, we're going to demonstrate with 2 8-pound weights. So the LCD should display 16 pounds, which if you put them on there, and you look on the keypad, it displays 16 pounds. So on the LCD, on the little sections, the first section is what planet is being called. So our default is Earth, and then the number, and then the P is for pounds. So if we look at the computer, we have our 2 tables which display which functions are used with which number on the keypad.
Now we'll give you a little demonstration of how this LCD can change as we push some numbers with the keypad. So for example, if we wanted to simulate our scale being on Mercury, we would press the 1. And you notice that first off, the first letter there changes to an M now. It stands for Mercury according to the table. And it's still in pounds, so we get 5.9 pounds. All right, if we wanted to change the units, maybe say to ounces, press the A, and you can see now that we are on Mercury and measuring in ounces. Now, if the value that needs to be displayed is larger than the LCD can display with the number of positions that we have a feature, this star, you can press, and that will change the order of magnitude by a factor of 10. So let's go to Jupiter, for example, in ounces. And currently we're showing 675 ounces. If we push the star, it will show 67.6, but then you notice on the right side one of the LCD bars has turned on to signify that that number needs to be multiplied by 10 to the first power to get an accurate value. If you push it again, 2 bars now turn on and it displays 6.7. So you multiply that by 10 squared, or 100, to get a more accurate value of what's really going on Jupiter. But it is small enough to be displayed now on the LCD. So some of the struggles we had with this project, we first tried to hijack a scale that we bought. We learned that the circuitry is not always the same. The scale we happened to buy didn't use an analog to digital converter inside. It used a complex method that was beyond our skills with charging and discharging a capacitor to determine the weight. So we decided to build our own scale using these load cells and this little amplifier and ADC module external from our microcontroller.
Yes, we then attempted to use I2C to read the values coming from our load cells. Evidently, these load cells, or coming from our amplifier, this amplifier that we have, it's the HX711. What it does, it's an analog to digital converter, which then allows the user to read the output. So like I said before, we attempted to use I2C. However, HX711 uses bit banging, in which each bit is sent within a clock cycle, where at the top of each clock cycle, one bit is read. And so that is put through a loop in our code 24 times to get our 24-bit number, which is then sent to our LCD code to be manipulated into a weight.
Yeah. Also, so when we were first using this module with the bit banging, we were reading in values incorrectly. We were shifting the bits further than they needed to go, and so we lost lots of information, and we were getting inconsistent values. And once we were able to fix that in our code, Scale practically worked. So this is our project, and we hope you like it.
Thanks for your time.